That includes all the components, all the Raspberry Pis, and also I had some old hardware also lying around. I had a Raspberry Pi 3 also, which was like an very old. I mean, it's not even that much. It's having like how much? Just 2 GB RAM and and dual core.
$2.
Yeah, that's it. It was a very like as I said.
$2.
Yeah.
How many dollars? One time expense, how much it cost?
No, not dollars. It is 31,000 rupees. Yeah, and it also includes all the hardware cost also, like your networking components. I'll show the pictures in a bit that how it looks like and everything. Uh, yeah. Then let's talk a bit about the architecture that I've set up for my home lab. Everyone will be interested, right? So I just have like a very simple setup. It's a one master. Yeah, sure.
It is a one question. We started with homelab.
Yeah.
Now, Mike, I think in order to digest all these things, we just want to understand that what is the application that we are talking right now? Like when we do the home lab, how do you set up and all this? Definitely what we are going to discuss.
Yeah.
Just if you can give us like what you are doing with this setup. Like
Sure,
what is your application? What kind of things you can apply and for which purpose you are creating this? So that would be great. Like if
Right.
you
Yeah,
get
yeah.
the idea also.
Sure, definitely.
One is cloud is different, but yeah, other than that, what?
Yeah, so when it comes to the applications, like why did I create the cluster?
Yeah.
It's basically like for me, I wanted to have first of all a learning environment where I wanted to experiment more about Kubernetes operators and all the things. That's one thing. Second thing is I wanted to also I also want to have my own Git repository where I don't necessarily need to have that as like GitHub or GitLab or someplace if it goes down or anything. Or it might be a situation that I might want to store it in Git, but I can't store it on some sort of a cloud environment or something like that. So for my own personal backups, I've used it. I've set up Git as well, GITEA, which is again a self-hosted GitHub application. It's your self-hosted GitHub, which you can use for storing your code and everything, your code and your things. The other thing that I'm using it for is, I have plans actually, is I want to also set up an image backup service where whatever photos that I have, whatever family photos or whatever photos that I'm having across devices in my family, I want to have them stored in a central place, and also it should be accessible just like Google Photos, right? So it's like kind of a Google Photos clone as well, which you can self-host and you can set it up for your image, like as a backup for your images. So yeah, these are some of the applications like which I have and / what I have planned. So yeah, that's the thing. Yeah, so let's talk a bit about the setup. I hope that answers your question, sir.
No, definitely.
Yeah.
What I like the most is the Git one that you said.
Yeah.
Everyone is looking for that kind of environment where they want to have their own code and because of this change in the era.
Yeah, definitely. So let's talk a bit about the architecture of the cluster. So I have 4 Raspberry Pis actually. One of them is not shown here. It's so shown. So I have 4 Raspberry Pis, but for this particular cluster, I've set up with 3 Raspberry Pis, where each and every I have one as serving as a master, and 2 of them are serving as my workers. All of these 3 are like Raspberry Pi Pis, which are of each of them are having like 4 cores and 8 GB RAM configuration. So that's the that's the setup of the each and every Raspberry Pi that's here. And for access to my cluster, if I want to have any sort of access to if I want to access my cluster from anywhere, I'll show it in the demo as well. So if I want to access, so my cluster is sitting back in Ahmedabad and I'm here in Gandhinagar, and I want to access the cluster from Smart Cells office, I can do that with the help of Tailscale, which is kind of a mesh VPN solution, which is based on WireGuard, which long story short, it kind of helps you to get access to your cluster, as well as some other components that you might have in your as a part of your home lab. There's also another component which is there, which I'll also show it as later in the demo. So I have something called as Pi-hole, which is kind of a DNS ad blocker, which works as an ad blocker for all the sites and everything. Like we all know, like how how cool Google is, right? That they take our data and just serve us ads. I don't want any of that. So and I wanted to block all the ads. So, but I also didn't want to install any of this on my client, on my browser, on my Mac. So for that, I went with a DNS-based blocking solution, which blocks the DNS entries for Google Ads and everything. So I have set up something called as Pi-hole, which is set up in another Raspberry Pi, which also acts as an exit node for this cluster. Where, for example, if any other clients, for example, my Mac, if I try to access any other website from my Mac, that traffic will go through that particular Raspberry Pi, which is acting as my DNS blocker. So that's how the traffic will kind of work. Yeah, so that's a short overview of this architecture itself. I'll also explain in the demo later that what is the tailscale and how it is set up. Let's talk a short bit about the k3s architecture. Honestly, it is more or less your typical Kubernetes cluster, where you would have your API server, proxy, and everything. But it also has some other few components that takes care of. So all the Kubernetes, all the Kubernetes server components, that's part of the k3s server. So all of these are packaged so lightly, like they are packaged in such a way that that your final resource utilization that will be much less when it comes to like setting up the k3s server. And also the other thing that it takes care of, if you are if you are setting up a distributed setup like mine, if you are working with one master node, your database, where your state is stored, usually you would see it in etcd, where all the state is stored. But in this case, it will be stored in SQLite. It uses SQLite as the database for storing your state. When you are working with a single master setup. If you have 3 master setup, then it will go set up with etcd, which is your typical Kubernetes cluster setup. Then it comes to your k3s agent, where you have this agent, which is essentially your kubelet. It has your kubelet, your kube proxy, as well as a tunnel proxy as well, which is useful for if you want to redirect traffic, send traffic to one of your pod which is hosted in all these workers. So for that you have this tunnel proxy. Underlying it uses container D as a runtime for running your containers. So yeah, that's a slight overview about k3s architecture. Anyone having any questions so far? Please feel free. Yeah.
Have you encountered the booting delay of Tailscale?
Not really, because so there is another thing that I'm using as part of my setup. Like for the operating system itself, I'm not using, first of all, I'm not using your typical Raspberry Pi OS. I'm using a lighter version of it called DivePi, which significantly reduces the booting time for the Tailscale.
Because I have installed the Tailscale, and
Yeah.
it takes, after starting the computer or the device, it takes around 10 to 15 minutes, which is really annoying.
Yeah.
So
You might want to check your process order, and you might want to see, take a look at how your what other processes might be running, because I've like in my experience I've not encountered this. Like when I switch on my cluster, it takes around maybe barely 2 minutes or so to get up and running and be connected to the network. Any other questions? Cool. Let's go on to the setup piece. So in this case, as I mentioned, so for my particular setup, I'm using DivePi. DivePi is a very stripped down version of Raspberry Pi OS, which is also based on Debian. but it removes all the other unnecessary components like GUI, all your other packages that might not be necessary. Like that might be useful for Raspberry Pi, but not so much for the Kubernetes part. So DietPi is kind of like strips down your OS and gives you a much faster booting experience when you are starting up your Raspberry. Also, once you have the Raspberry Pi flashed and like you have the DietPi configured, there is also another thing which with DietPi is that you can set up all your booting time, like all your configuration. So whenever like you can take example of maybe setting up your laptop, right? So whenever you are like setting up your laptop, you are flashing your Ubuntu OS, and then you want to set up all the customizations, right? That this will be my SSH key, this will be my theme and everything. So Raspberry Pi DietPi allows me to configure everything as a single boot command line text parameter, like a single file, where I set up all the things about like what's the static IP I want, what's the SSH username I want, what is the SSH key I want to set up, what's the host name I want to set up, everything. I'll also show a bit about that as well. So yeah, that's how I have set up like DietPi. That way, the entire setup, it took me around like 15 minutes, all the way from like flashing and everything, like flashing the OS and setting up everything. It took me 15 minutes to set up one Raspberry Pi. That way, like around 45 minutes just to have the OS and everything configured. So yeah, that's the speed I've seen with all the setup. Then I'll talk about, then also k3s is also like pretty simple. Like if you go to as you can see, it's just this much. This is the only command that it takes to set up your k3s cluster on your Raspberry Pi. So it's pretty much very simple when it comes to like running the k3s cluster. Like this is just the this part. This is just for your initial like your master node setup. And when it comes to for the agent setup, you just need to there's just one other parameter that you need to take care of when setting up the agent. So that's also like pretty simple, pretty much like straightforward setup process. Then, yeah. Yeah, so as I said, once you have the Kubernetes server itself set up with that setup script I just showed, you have you will have a token. It will present you with a token, and once you copy that join token and you run the k3s join command, there's a simple like setup for that. Once you run it with that token, that node that you have run this script on, that will join as a part of your cluster. So yeah, that's the simple thing. And once your cluster is all up and running, you get this kubectl once you run kubectl get nodes, you'll get all the nodes which are part of your cluster. And by the way, once you set up the k3s cluster and everything, it will set up all the DNS certificates for you. It will set up the Kubernetes context with whatever the certificate data that's there. And if I run the kubectl get nodes, that will show me all the nodes which are there. It means that I am able to connect to the cluster and I am able to see what are nodes that are part of your cluster. There are some, usually there is some challenges which are there when it comes to optimizing your resources. So I just mentioned, right, I set it up with DietPi. So that's one of the reasons, which is I wanted to have my resource utilization as low as possible for my Raspberry Pis. So for that, I've chosen DietPi. There are many other options like Talos is there, Ubuntu on server is there, and everything. But it totally depends on what's your node configuration, how much your Raspberry Pi's configuration is, and depending on that, you can like choose which OS to pick up. Then there is also another challenge that is so you will always have limited CPU and RAM. The maximum configuration that you can buy today For Raspberry Pi, that's 16 GB configuration, nothing more than that. If I want to have, if I want to, let's say, run any LLM workloads, or I want to run Olama or anything like that, you can't do it because it's that much of resource constraint. So, and whenever if you want to set up any other things like GPU or more faster storage or things like that, the cost will add up automatically. So it totally depends on because of this you need to also take care of this kind of like capacity planning. Then also as I mentioned, there's also since we already have these constrained resources, so you will also need to ensure that you always have CPU and memory resources and limits always configured for your pods. So I mean, one can agree, right, that if your pod is requiring like 1 core of CPU and 2 GB of RAM, that's already like one-fourth capacity is consumed behind that particular pod, right? So it's like you don't have that much of resources to play around with. So this also like kind of teaches you about like resource optimization and capacity planning kind of concepts, which are like kind of necessary when you are into DevOps and site reliability engineering. There's also some networking considerations that you need to take care of because there are, for example, when we talk about Kubernetes, so I mentioned, right, that K3s comes with its own goodies. So one of the goodies is its own built-in CNI, like your container network interface. So usually you might have heard of other projects, like for example Calico, or Shivla just mentioned about Cilium and those kind of things. So those are all like your container network interface. Which essentially like decides that how your containers would be talking to each other and how your networking is set up. So with K3s you get Flannel. Flannel is one of the like more resource friendly. I mean, I would say resource friendly CNI, which has very lightweight network like networking mechanism when compared to like Cilium or Calico or others like that. There's also another thing that Raspberry Pi also comes with its own Wi-Fi configuration as well. Like you can connect to Wi-Fi using Raspberry Pi. Also, although it sounds tempting and keeps your setup a bit more clean, I would advise that might not be the case when it comes to like setting up your home lab, because you need a constant Ethernet connection first of all, and also you need this thing. You need a constant Ethernet connection. You can't have your Wi-Fi getting disrupted and your home lab access is like going kaput. So so for that, always I would suggest to use your LAN connection and have LAN cables ready whenever you are setting up your own Kubernetes cluster using Raspberry Pi or any other hardware for that matter. Also, since when we talk about Kubernetes, another difference between Kubernetes in cloud and versus Kubernetes on premises, you don't usually have a load balancer. That is, so if anyone who is coming from EKS world or GK world or anyone who is coming from cloud, if they set up the service type as load balancer, they are just they have a cloud load balancer, you have a static IP, and you are on your way home. But not in this case. You are just limited to like using either node port or configure your ingress, or you are limited to using node port only. That whatever port that's exposed, you are only able to access your service using just that port. That's it. You can't have load balancer and things like that. Although in my setup there is a slight difference for that, like how I have set up external networking, and for that also I'll show it a bit in my demo as well. Also, some things about storage constraint, like I mentioned, that whenever you are running, for example, if you are having your Kubernetes cluster and you are setting up databases, for example. Let's say you are developing your own application, you want a Postgres database, but if you try to set up the database on your SD card, that will wear out very fast, because again, like I mentioned, SD cards are not the fastest way to access your data, and you also need to take care about this also, that your SD card doesn't wear out, because your OS itself is also hosted on that particular SD card, and also you can't just set up the database on the same drive as your operating system is working on. Usually you would go with like a USB based SSD card, USB based SSDs. That's not available here. You usually use your external SSD drive. You can use your external SSDs or external hard disk, and you can have them connected with your Raspberry Pi, and you can use that for your storage. Or you can go with like a network file system. That's totally up to your choice. Let's talk a bit about observability, because as mentioned in my talk title, there's also a bit about observability. So generally, like whenever you are having this much of Raspberry Pis, this much of hardware, and you are having this much of software, you usually need some sort of monitoring in place, where I would like to monitor that how my application is behaving, whether it is going down or not, and what other, if I want to be interested in any other metrics that that my application might expose. So I can have all the things, and also I want to have all access to all the logs which are there. I don't want to be running blind when it comes to troubleshooting. Yeah. So for that, so how do we tackle this particular challenge of having lightweight tools while also being able to monitor the cluster, right? So we'll talk about that. So generally, when it comes to like any sort of observability, if I want to implement any sort of observability using open source tools, you usually go with your usual suspects. That is Prometheus, Grafana, and Loki. Prometheus is for metrics, Grafana is for UI, for dashboards, and Loki is for logs. Right? That's you might expect that might be the setup in this particular case, right? There's a change. That I'm not first of all having all of this set up in my same as my Raspberry Pi cluster. I'm having this set up in a centralized environment, someplace central. But what am I then? How am I getting all the logs and everything? So if I want to get any sort of logs, any metrics, or any sort of like telemetry behavior from my Raspberry Pi based cluster, I have deployed something called as Grafana Alloy, which so if anyone has used ELK stack here, ELK, yeah, right? So you might know a component called beats, file beat, metric beat, and everything. So this is a similar kind of thing, but it's mostly like it's from Grafana that you set up for your for all your data. But the other thing beauty about Grafana Alloy is you not only, and it's by the way it's open source, it's not a paid tool. So when we talk about like Grafana Alloy, you not only get logs and metrics, but also you can have it set up as your open telemetry collector. So if your application is also like sending out any sort of telemetry data in an OTel compatible format, and I want to get it scraped and I want to have it visible in my centralized dashboard, then I can use Grafana Alloy. I can configure the Alloy configuration appropriately to get it from the particular OTel metrics, and have all the configuration in my UI, in my Grafana dashboard.
So, is there any setup needed on
the cluster? Yeah, yes. In cluster also I have the similar setup in my environment. I'll show it in my demo as well.
So is it running as a daemon set?
So yeah, it is. So the Grafana Alloy itself, that's running as a daemon set, because I need to collect all the logs from each and every Kubernetes node, right? So I need to have it running as a daemon set. And like I mentioned, I wanted to have a central place to get all the dashboards and everything. So I'm using Grafana Cloud as my place to have all the dashboards. And Grafana Cloud by itself is also having a very generous free tier. Like even if you are just a hobbyist, or just of starting to explore homelab, and you want to have all the dashboards in a single place, then Grafana Cloud is the way to go, and you can access it from anywhere in the world. So that's also not a problem. Now I was talking all the way about like I'll show you the demo and everything. I think now is the demo.
Create the demo board.
Yes, definitely. Great demo board. Sorry, I have to sit up for this. So let's first talk about the cluster itself. Let me open up the files for you. In a minute. Yeah, so this is my Raspberry Pi cluster itself. This is how it looks like. So the top one, the bottommost first. Let's start from the bottom. So at the bottommost is my Raspberry Pi 3, which acts as my Pi hole that I was talking about, which works for like blocking my DNS traffic, and it also acts as an exit node for my tailscale VPN connection. Then then the other two nodes above that, these two are the worker nodes that I have as part of the cluster, and this is my master node. So as you can see, it is a pretty simple configuration, and I just have a like little nifty cluster case just to have it all set up and configured. Now let me show the short video about that. I think you might not hear it, but there is some noise that is there. As you can see, this is all of my clusters. They are connected via Ethernet. I'm not using a managed switch here. I'm using an unmanaged switch. So a small difference between unmanaged switch and managed switch is that you don't get to have your own IP ranges just for the cluster. For example, if my home network is in 192.168 network, and if I want to have 10.0 network just for my Raspberry Pis, I can't have that because my switch itself does not have that kind of capability. So I have to make deal with what I have, right? So I went with that for this one. Let's test this out. Yeah. And here's my tailscale network. I'm connected using the exit node, and let's show a bit about this. Let's say I'm not connected to the I'm not right now connected to my tailscale network. Now if I try to access any of the website, right? For example, this is an ad website that I have, right? It will give me all the ads and everything. It gives me all the ads about in this case it gives me ads about laptops and printers and everything. Okay, I don't want Google's ads. So I turn on my tailscale network. I'm connected to the exit node, right? And now if I try to access, my ads are no longer there. I no longer see any sort of ads during my browsing experience. So this is one of the applications that I have on my Raspberry Pi cluster.
Aditya, could you explain what happened here?
Yeah.
Some of the people may not understand what happened over here.
Right. So let me explain a bit on this part. So before I was not connected to my tailscale. All the DNS records for the Google servers, Google's ad servers. In this case, it might be Google Tag Manager or that kind of thing. Those were their DNS entries were getting resolved to the IPs of the server, like to the ad server, and because of that, my browser was able to access to those ad servers and was able to serve me ads. Now, once I turn on my Pi hole, once I'm connected to my tailscale network, what happens is all the DNS queries, every single DNS query that is running from my laptop, that will go to this particular exit node. In this case, I have the exit node as, let me show. Yeah, as you can see, this is having multiple nodes. So this is my Pi-hole machine which I have it. It's also having like a, I wanted to mimic Cloudflare a bit, so I just, I did 100.105, that kind of address. It's a bit unique address. So all the traffic that is originating from my laptop, that will go through this particular instance to the bastion, and then it will send that traffic. So Pi-hole sees that this is an ad server. I want to block the DNS entry, so it blocks the DNS entry and then let the other traffic pass, and the other traffic, in this case, the rest of the web page is served, while the ad ones, they are failing, ad queries, they are failing. So yeah, that is the summary about like this.
So earlier you were directly connected to the internet,
Yes.
but now you are routing your traffic through your homelab.
Yes.
So you are filtering out all the DNS requests for
Yes.
any ad servers.
Yes.
Through a tool called Pi-hole, right?
That's right. Yeah. Thanks for the update. Yeah.
Do end user experience any latency in this case?
End user, in this case, it's just me, right? I don't experience any latency, so I could. Usually, yeah, I mean, see, for my case, it's this homelab is it's just like for me and maybe even one or two more users. Like that's about it. Like it's not a very big enterprise use case. And as long as there is no if one or two users are able to not view the ads while not facing any latency issues, that's totally fine with me. So that's the kind of expectation that I have with this particular homelab. I hope that answers the question.
So Tailscale is your mesh,
Yes.
and that is the entire network that is behind this entire cluster.
Yes.
The Tailscale is connecting to his homelab. Tailscale is not, it's just a VPN mesh. It is helping him connecting to that cluster from outside his LAN. Right now,
So it's a VPN.
cluster is inside his
Yes,
LAN.
it's
Yes,
a
it's a
VPN.
VPN.
It's a VPN, sir.
Yeah, you can
Yeah.
say that.
Is it like because I don't know? Is
Yeah.
it free or what? Can you just?
Yeah. Okay. Yeah. So let me also speak a bit about Tailscale as well. Tailscale I'm using it's completely free. It allows so the free tier it's also generous. It gives me up for 3 users. It gives me access for 3 users and up to 100 devices. I can connect up to 100 devices to this Tailscale network and still be able to access this as long as I have 3 users.
100 device means 100 IPs.
100 IPs, yes.
It gives access to all 100 IPs
Yes.
to all the 3 users.
Yes. But again, you can also define access policies and you can also control the access that which user wants to access which particular device or which group of devices. You can also
No limits to egress or ingress.
yeah, no limits as such to ingress and egress. Yeah. So yeah, that is about this particular Tailscale solution. Let's talk about the k3s question. Let me show the cluster. Right. So as you can see, I am not connected to Tailscale, and let me show a bit about my Kubernetes context as well. So I have this is my Rancher desktop, which is my local, which I'm using for any sort of experiments or anything, but it's just there. Second, which I have is PyQ, which is the name of my Raspberry Pis based Kubernetes cluster. Now, if I try to, for the time being, if I try to, let's say, Kubernetes, I try to, let's say, do a test. Yeah, it works because I'm connected to the Tailscale network. Yeah, I'm connected to the Tailscale network. Now, for example, now if I'm disconnected from the network. Now, if I try to get it, it won't work. It will time it because I'm not connected to it. It will take its own time. Just cancel it.
wanted to disconnect, you mean that part?
Yeah, I disconnected from my Tailscale network, my VPN network. I disconnected from VPN. As you can see, so it failed. This is my master IP. It tries to connect to my Kubernetes API, which is at this particular Tailscale IP. At 6443, it was unable to connect, so it failed. I tried to connect back, it will work. So, that's my paper. Should work. Yeah, okay. So let's show a bit about like the egress part, right? For example, I have some applications and I want to, access it from my Tailscale network. So how do I do that? Let me first, open up the UI. Here's my entire thing. I'll also talk a bit about what this Grafana thing is about. Let's talk about a bit about this thing. Okay, right. So I have something called Tailscale operator, which is running in my cluster, which allows me to have any sort of like egress IP for my applications. For example, I have some application which I want to access, which is hosted inside a Kubernetes cluster, and I want to have an egress for it. So how do I go about that? So I do have a sample application here. Let me just open up my. At this point, everyone is now using Windsurf or some sort of AI-based editor at this point, so it should be no surprise. Smart. I hope it is visible for everyone in the back. Yeah. So I just have a very simple example of egress and everything that I have here. It's like a run-of-the-mill Nginx pod and everything. So it just have a simple pod, and I have a service, and then I have an egress which allows me access to this particular application. Now if you note here, this is an egress class name. In this case, I'm using Tailscale as my egress class, which is again this was made possible because I've deployed something called Tailscale operator within my cluster. What it does, let me show you in action as well. Okay, I have all the ingress and everything created. Now let's jump back to the cluster. What happened? Yeah, as you can see, that this is creating another container, which acts as kind of a sidecar for that ingress resource that I created. For that, it is creating this Tailscale sidecar. What it does is it runs a Tailscale service behind the scenes, and it creates. It's already having all the authentication information about like how to connect to authenticate to Tailscale and set up all the routes and everything. So it's already there. And if I go to the Tailscale admin panel for a bit, let me jump there. Yeah. So here's my machines that I have. This is the Bastion master worker and everything. So you can see here, right here, it creates a Tailscale route for me within the Tailscale that with the particular name in this case, it's using the namespace name -nginx ingress, which is the name of my ingress, and this is the IP for it. Now, if I try to access this particular URL, let's say, yeah, so let me just switch to the ingress resource. So here's the IP it gives me. So this is the address, this is the endpoint name, and this is my tailnet URL. In this case, this is unique to me, and this is the Tailscale IP. This is the address it creates for me. Now, if I try to access this particular URL, it will work. Again, it loaded fast because there was some cache, but so it works this way, right? So if I want to access any of the applications behind, which is there on my on-premise cluster, which is also behind a VPN, and I want to set up the access for it, I'll use a tailscale operator and set up this kind of access for my application. There are also various other solutions in the market, like for example, you can use Cloudflare tunnels, you can use other like your Nginx ingress controller or things like that. But I mean, I chose tailscale because it was like pretty seamless to set up, and it was straightforward for me to like set up all the Kubernetes nodes and everything. And also with the recent, if everyone has been watching the news, you might see that this week and even last week before, we also had outages with Cloudflare. So that kind of like reduced my trust with Cloudflare, and I wanted to move away from it. So this kind of just gives me it gives me the power for the having all the ingress and having this kind of setup. So yeah, that's a bit about the Nginx itself. Like this is things about all the ingress and networking part. Anyone having any questions so far?
So we can also have a static IP if possible, right, instead of tailscale.
So yeah, static IP is also possible, but again, if you want to have that kind of setup, you would need to set up a VPS server somewhere, like some sort of VPS server or someplace, which again proxies back to your network, and then sends your traffic from there. So that way, the access it's kind of a convoluted way to access your applications, but this is like kind of gives me a sort of a straightforward way. It also kind of gives me a DNS as well, and it also limits. And also, by the way, this also gives me a capability to expose this to the entire internet as well if I want to. So I can set up that, but I am not set up just for the demo purposes. And also, other thing I don't want everybody to just access my private server and just cause traffic issues for me. So yeah, so that's all about the networking part. Let's jump a bit into the observability bit. So as I was showing earlier, there are some pods that are here for all the things about monitoring. So what I've set up is I have something called a node exporter, which exposes or which sends all the metrics to the, in this case it sends to the Grafana server, Grafana cloud. And also what I have is something called as alloy metrics, which again collects the metrics from all these node exporters and sends it to the Grafana cloud. So alloy is actually the one which does the remote write, whether it's to Prometheus or whether to Loki. So yeah, that's what it does. And also there is all the logs, all the logging pods that are here. These are also deployed as daemon set, as the gentleman mentioned earlier, that all the logs and metrics pod, they're all deployed as daemon sets, and they are like the ones who are shipping the logs and metrics to my Grafana cloud instance. Now if I talk a bit about this thing, let me show my Grafana UI. Right, so here's I have this as in my Grafana instance, my Grafana cloud instance, that I have this setup. And also Grafana cloud is also like gives out a pretty free, generous like free tier if you want to like do self-hosting and do kind of those kind of stuff. So it's like these kind of like observability cost and everything is kind of becomes free, but again you have to like bear with the limitations that comes with the free tier. So yeah, that's more or less about it. Yeah, let me show the dashboards that I have. So let's just talk about the Kubernetes cluster itself. So it does have this dashboards that I get it out of the box with about like how many nodes are there, what are the namespaces. It gives me like the top running containers, what's the spec and everything. Now if I talk about clusters, here's my cluster. It gives all the information. Like as I said, it's having each server is like 4 cores, so it gives you a total of 12 cores and a total of 24 GB of RAM, physical RAM which is available. and it gives me all the things about like I've not set up about cost and things because all those cost monitors and everything that's kind of irrelevant when you are dealing with your home lab, right? So yeah, it gives me all the things about like the CPU utilization, memory utilization, and everything. And yeah, it also gives me about like storage. I don't have energy ones configured, but this is something cool that you can. I think someone was in the crowd was also asking. Sandeep, I think you were asking about like that what's the energy usage and everything. So I can have that kind of tracking as well. I'm not just set it up, but just because I don't need it. It's not that much of a thing for me. So yeah, and also about PVCs. PVCs I don't have it. I mean, in this cluster I don't have it just yet because it's still a work in progress. But yeah, you can I can have all the metrics and things about like what's the PVC usage and everything. I don't have anything. Networking also gives me the capability that how much data I'm receiving versus how much I'm transmitting. Within this, just within the cluster, there is also something I want to show you about the dashboard that I have. This is about. I think it was this one. So this is my Pi-hole UI. This kind of gives me like how much DNS traffic went, how much was blocked, how much percentage of it was blocked, how many domains it was querying. And this is just from last week's data. You can see that our machines are sending out a lot of telemetry to various other services. It gives me all the things about how much, what's the traffic pattern, how many DNS queries were done, what was the things that were done for how much of it was blocked, how much of it was which client performed the most activity. So in this case, like if I take this, this snapshot for example, it gives that my phone is actually sending out a lot of DNS queries compared to the one of the Kubernetes nodes, worker node that I have here. Also, it gives me that from where the DNS queries was answered, what kind of DNS queries, what are the top permitted domains that was there, what are the blocked domains. As you can see, our friend Google just likes to talk a lot. So that's the thing about this thing. You can also see like a kind of a behavior that like how you kind of get an insights also about like how your devices are behaving. So this kind of like helps you get to some more insights and take some more decisions around various other things that you want to have.
The block domains, you configure this domains to be blocked.
Yes. So yeah. So for when it comes to Pi-holes, Pi-hole also has this capability of adding your own custom block list. So any of the block domains that I want to block or anything which I don't find, I don't want anybody to allow to access. Let's say, for example, I don't want anyone to access Instagram at my home. So I can just add Instagram's domains into the block list. That will then moving forward, if someone tries to route the queries through this cluster, through the Pi-hole, those queries will be blocked. And these block lists, they are like very much like available in public. They are available in public domain. You can pick up any of the popular block lists that are out there, and you can block most of the domains. So even with the default, not default, but one of the recommended block list, if you try to configure any of those, it would block around like 70 to 80% of the ad domains that from which the traffic is originating. So yeah, that's about it. You can see that it's having 84,000 domains in the block list which is there. So you can imagine like even going with the normal, even if you go with the baseline configuration, this is also like more than enough for most of the users. That is mostly about the dashboards and all the things that I have so far. And that's about that mostly concludes the demo. Let me switch to the presentation once again. So as I was talking, there were some best practices also that you must follow whenever setting up these kind of whenever setting up Raspberry Pis for Kubernetes. You should be keeping your operating system as well as your Kubernetes distribution minimal. it should be like as much of light footprint as possible, and also try to use ARM images, obviously, that goes without saying. You can also limit the pod. You should also limit the pod density that's there within each of the clusters. In my case, I have kind of like if you have that much of resource constraint, you can kind of like you can allow your master node to also act for setting up your like hosting all your workloads. But ideally in production you would not see this in practice because master nodes are always like kind of they are like dedicated setup. But if you are like resource constraint, you can allow that kind of things for your liking. Then any sort of long-term storage, if you want to configure, try to prefer SSDs or hard disk drives. So that's how you should be going when it comes to configuring your storage. Also, you should configure your monitoring early, and you should monitor it often when it comes to monitoring your stuff, right? Whatever your software, whatever DNS traffic is, all the things. So yeah, that's about it. And yeah, Kubernetes on Raspberry Pi, it is like a practical solution. K3s also kind of makes it lightweight to operate, and using this kind of open source observability. I mean, most of the components are open source. It's just the Grafana. I mean, the place where I hosted it. That's the one which is which can cost you. But again, if you be smart about like where to set up your observability solution, that can also help to keep your cost low when it comes to the observability things. Yeah, I think that concludes my presentation. If anyone's having any questions, happy to answer.
How is Pi1 configured? Is it configured in the cluster?
So yeah, so Pi1 is configured as a dedicated node. I have configured it as a separate node. Because again, it's just me that I'm using it, right? So, but I can scale it up only up to like few users. But if in case if I have a very large joint family, or let's say I want to have it for my company, then and I want to set up this kind of ad blocking solution, then I can set it up in an HA manner using like again I can use Kubernetes to host Pi1, and then you can like set it up that way for your DNS configuration. But ideally, it is generally recommended that you set it up as a dedicated server, because that kind of gives you your dedicated static IP also for your DNS. Yeah.
So you already have Bastion in your setup, right? But still I saw that all your nodes were there in Tailscale. So is it because that you don't have a managed switch and you have all the internal IPs open? That's why you require Tailscale in each and every node, and you are not accessing through your Bastion only?
Yes, yeah, that's the thing actually.
So otherwise you can have something similar to what we have in public cloud, like we can have a Bastion server, which is the only server which is connected through Tailscale, and you can connect to our cluster through that, right?
Yes.
So even utilizing only single IP address from
but in this case also I do have set it up as a single IP also, because what I have configured is all the Tailscale nodes, they are all, I mean all the Kubernetes nodes, they are configured for Tailscale. But then again, I have also configured something called as subnet routes, which allows me to have all the Kubernetes IPs, that is the internal Kubernetes IP. So this is one of the caveats that I faced with my setup, that whatever if I just set up just plain Tailscale and just be done with it, that's not going to work, because any of the pod traffic, that is the 10.43.0.0 traffic, which is the default traffic which is used by the in this case Planet for all the IP communication, that will be blocked by Tailscale. So for that I had to set up this subnet routes and have to have them onboarded within Tailscale. And also if you set up Tailscale in such a manner, you really like don't need a Bastion node. So let me give another example of that. Why did I say that? Because so now, for example, I don't have access. Let's say I never had the Bastion in the first place. I mean Bastion, I just gave it a name. It's honestly it's a DNS query for me. So now, for example, now if I want to access any of the nodes for any sort of troubleshooting I want to do, I can just simply say, and you can see these are all also enabled. You see this SSH mark, right? Which means that these are all available for me to connect via SSH. So if I go here, I set up the Kubernetes username that I want to set up, that I want to connect with. I authenticate with GitHub. It gives me an SSH session directly to my machine without any sort of passion or anything. So I can have this kind of gives you like that kind of Google kind of experience also for your notes, right? But again, all of this is private and you can't like access it just like that. So yeah, that's the one of the other benefits that I get with Tailscale. I mean, yeah, for this access. I don't really need a passion, but I can.
So you don't have a mesh thing then in that case?
Yeah, I don't have a passion. The passion is just a name. It's just a name in here.
I'm talking about the mesh. You don't have a mesh like you generally have a connected component like Istio kind of things. You don't have here, right?
That's a different thing. Istio is a service mesh. This is a VPN mesh. So he is actually using VPN mesh. That was the concept. Usually in public cloud, we use a bastion server to hide our private clusters behind it, right? Right now he is exposing all the servers through Tailscale, so he can directly connect to it without using any bastion. That's a VPN part. What you are referring to is the service part. That is the Istio is used for. So if you have multiple services running in your cluster and you want to have a service discovery there, you use Istio for that only. He is not using that.
Yeah.
And how the worker nodes and master nodes are communicating through sub routes?
Yes, they are all because these are connected via the subnet routes, right? These you can see this marked as subnets. So it does have its own subnet routes. That is the Kubernetes pod network that's advertised as a subnet route as part of this. So each and every node. So that's how master can talk to all the nodes. Master can talk to the workers because of that subnet routes that are advertised. And also when I'm connecting this thing, so k3s by itself is also having their own option of setting up via VPN. So let me show about that as well because that's the interesting thing. Let me show you. Yeah, okay. So let's connect via the SSH itself that I have created earlier. Right? We have to sit down for this. So if we go to this one. So this is my service file for the page for the k3s. Now if you see here this particular thing, you see these lines, VPN on. These are the lines. This is actually what's allowing me that whenever this Tailscale, whenever the k3s would start, that would join as part of the VPN network with this particular join key that I have here with all the SSH flag that I mentioned, right? The extra args which is there. Because that extra arg is present, that's why I'm able to do SSH directly via the browser on these nodes. So I hope that answers your question.